Hello, my lovely warriors. Do let me know in the chat box if you guys can see me as well as hear me loud and clear. Hi, Success Sikh. Hi, Pavitra. Hello, Kritika. Hello, Hari. Welcome to the iDoc series. This iDoc series is meant for all the NEET aspirants, all our future doctors who want to say, I am a doctor very soon. And this is your NEET 2022 preparation. Even if you're watching this recorded, no problem, guys. Make sure you stay tuned till the end. Welcome. Hello, Satiti. Hello, Kirtika. Hello, Success. Hello, Sivarama, Bonde. Welcome aboard, my lovely warriors. And this series has been divided into blocks. So today we are going to do block 3. Block 1 and 2 was done already. We are going to focus on high weightage and the most important, the blocks or the units which will help you boost your score to at least 120 to 150 marks, no matter what you're scoring right now in your, NEET mock tests. So today's block number 3 will have questions on electrostatics, Gauss's law, current, electricity, capacitors, magnetic effects, as well as EMI. So all of this in today's session. Thank you very much, guys, for joining in. And my name is Shreyas, in case you do not know me yet. And I'm the physics master teacher who has been with all the wonderful kids who have gone into all the top-notch colleges and who had believed in themselves, as well as all the teachers as well as the system who was working very hard for them. So thank you very much for tuning in, and my name is Shreyas, and you can also check me out on my Instagram in case you want to know more about me or get in touch with me. So before we begin, do not forget to smash the like button and also hit the subscribe button, because only when you hit the like as well as the subscribe button will you get more videos of us, or else you might miss out on the important aspects, the lectures, the preparation, the strategy, because that's how YouTube algorithm works. So smash the like button, and that's your Guru Dakshina as well, and also hit the subscribe button in case you have not yet done that. Okay, so let's begin, guys. Let's begin. Okay, hello Harita, hi Shahiti, hello Sonisha, please explain the answer. Yes, I will be explaining the answers, bacha. Okay, so you have boosted your physics from 80 to 120, working towards 150. That's a good improvement, Kirtika. That's very good. Hi Alisha, welcome aboard. Good evening. Hello Hydrogen, what a name. Hi Ritika, hello Priya. 90 percentile, can you improve in the second attempt? Definitely, Priya. I think you can easily reach 97 to 98, easily, with a little bit of hard work and some strategy and some planning. So let's start with electrostatics, guys. Are you ready for starting electrostatics? Okay, and if you're ready, go ahead and let me know in the chat box by putting up a smiley or putting up a yo or putting up a heart, so that I know you guys are awake, ready with pen and paper, and your minds are open. A quick question for all of you. What's the value of epsilon naught? Just put it up in the chat box, just to refresh your memory. What's the value of epsilon naught in SI units? Just put it up in the chat box. Good evening, Gautam. Let's start. Yes, what's the value of epsilon naught? Just to freshen up, this is like a warm-up, like how you do warm-up before you start your PT or exercises. So just a warm-up. Okay. Yeah, oh my God. Alicia, NEET 2023 students here for revision. Wow, very good. Looks like you already started with electrostatics and magnetism. All right, students are ready. Yes, it is 8.85 into 10 to the power minus 12. Very good. So let's get started, my warriors. Lots of questions on electrostatics and Gauss's law coming up on your screen, and here it is. A proton moves a distance d in uniform electric field as shown, then which of the following statements are correct? It's a MCQ, that means more than one option is correct. Now you might wonder, sir, in NEET exam they will not ask multiple correct, only one option will be correct. But there have been times where what they do is they give 3 or 4 statements, and then they give options like statement 1 and 2 is correct, statement 2 and 4 is correct, statement 1, 2, 3 is correct, all statements are correct. So those kind of options can come out. So that is the reason why sometimes you should also solve some MCQs, not just singles correct option questions. 97.1 percentile, 96 in physics. That's good. That's good. And you being a NEET aspirant, that's very good, Darshini. I'm pretty sure you're going to rock your physics exam. I want you to get minimum 150 marks, Darshini, in NEET exam. Okay, so what's the correct answer, guys? So first of all, it's a proton. If it's a proton, the force on it will be towards the right side. So this is the direction of the force. but the displacement is towards this side. So hence, the proton, if it moves this distance in the field, then the work done, okay, which of the following statements are correct? The electric field will do definitely negative work. So work done will be F into S into cos of 180. Cos 180 is -1. Hence the work done will be negative. And you are making it go against the field. If you make it go against the field, so if you make it go against the field, you will see that the potential energy will increase. It will store the energy. Like when you take a ball and you raise it up, you're going against the gravity. The potential energy increases as you go against the gravity. Same way, if you go against the field, since the force is opposite to the displacement, you will be storing energy. Hence, the potential energy increases. Option A and B are correct. Option A and B are correct. Is that making sense, everybody? And remember, the entire PDF of today's session will be available to you in the Telegram channel. Now, where will you get the Telegram channel? Go to the description box. In that, there will be many links. One of the link will be join Telegram channel. Also, you will see other links as well. So make sure you are a part of Telegram group, because that's the only way you'll get PDFs, homework solutions, updates, notifications, etc. so that you do not miss any classes. Here is the next question. A charged particle is free to move in an electric field. It will. Now, I want everybody to spam the answer in the chat box. If you take a charged particle and you move it in electric field, it will travel. Where do you think it will travel? Along a straight line? Along a line of force if its initial velocity is 0? Along a line of force if it has some initial velocity in the direction of an acute angle with the line of force? Or none of the option? So good, nice to see you back, bacha, after a long time. Okay, think about it. If you have an electric field line, let's say like this, then if you have a charged particle, the force on it is always along the tangent. The force on any charged particle is always along the tangent. But that does not mean the velocity is also along the tangent. See, if I give it a velocity in probably this direction, then the force will make it go in a curved path. The path will be a curved path if you give it a velocity like this. But if you make it start from rest, then what will happen? It does not have any velocity. So if velocity is 0, then the velocity will be after some time, okay, because the force is here, after some time it will go in this direction only. So always along the line of force? No. Along the line of force if initial velocity is 0? Yes. Along the line of force if it has some velocity in some acute angle direction? No. If it has some velocity in the acute angle, then it will go in a curved path. It will not be along the electric field. Hence, this option is wrong. None of these is not correct because this is correct. Hence, this is also wrong. Option B is the correct answer. So, a lot of students think the line of force also is the line of path of a charge. No, the line of force is not the line of path of a charge. That is only the path of the charge if initial speed is 0, then at that initial instant, it will have the velocity in the direction of the field. But the moment the field and velocity make an angle, it will go in a curved path. Very good, no primary, Alisha, very good. Oh no, Sukhbuk and Saran, I think you gave the wrong answer before. Okay, be little bit careful. Okay, Sukhbuk, yes, it is B, bacha. Moving on to the next question. Now, these questions are very important and we are doing this unit wise so that you know where your weak point is. So when I divide this unit wise and topic wise, I am trying to keep as many variety of questions, as many standard models of questions for your NEET preparation. So the moment you do not get anything, you know you have to exactly study that particular topic or solve more questions on that, right? So be with me till the end because many models, many patterns for the NEET 2022, most expected questions are going to be covered over here. All right. Okay. Okay. C says along the line of force. That is wrong, Sukhbuk, because the velocity was at an angle. If velocity is at an angle, it will not go along the line of the force. That's what I showed you over there, right? It goes and in a curved path. It does not go along the line of force. Okay. Now what about this question? Find the field at this point. There are charge sheets. Each charge sheet will give field. Like this sigma charge density will give a field over here. This will be repulsive in nature. These two will create attractive fields because it is negatively charged. So at point P there will be electric field downwards because of -2 sigma, and because of minus sigma also the field will be downwards. So will the fields cancel or will they add? Look at the directions. Sigma will give downwards, -2 sigma at that point will give downwards. So all the fields are getting added. Hence the net field will be, because of this, it will be magnitude by sigma by 2 epsilon naught, plus because of this, don't put -2 sigma because I have already considered the direction, okay? So no need of that. So plus 2 sigma by 2 epsilon naught, plus this one sigma by 2 epsilon naught. 1 plus 2 plus 1 is 4. So 4 sigma by 2 epsilon naught. So it is nothing but 2 sigma by epsilon naught downwards. Now downward direction, this is plus z, this is minus z. So it's along the negative k hat direction. Negative k hat direction. Hence option B is correct. Students get confused and they mark some random answers. Okay, I hope this is clear. Jaya Bharati, NCERT questions are not so important for NEET point of view. You have to solve PYQs and you have to solve single correct option questions because NCERTs are theory. Okay, give reason or numerical or those kind of questions. In NEET exam, apart from NCERT, you need to move on to some other questions. A lot of students just stick with NCERT and they get only 80 marks to 70 marks. So if you want to move beyond that 70 marks, 80 marks range, you have to solve more MCQs. You have to solve from Arihant, you have to solve from Tattva, you have to solve from assignments, you have to solve from mock tests, you have to solve lots of books. That's when you get above 150 bacha. Okay? So NCERT will not help you for high scores in NEET exam. Remember that. Okay, moving on. A particle of certain mass has charge plus E, and there is another particle of 2m mass, 2e charge. Both are allowed to fall from rest in the same potential difference. The ratio of their speeds will become. Doing Tattva very good, Alisha. Yes, PYQs, some of them are PYQs by the way, Badri, and I will be conducting another session. Maybe in that probably we can do PYQs. But this is a mixture of PYQ plus, very interesting questions which have been framed from different books, different authors. Okay, sometimes these are not direct questions also, they have been modified so that you get multiple concepts in one question. Okay, many of them are also inspired from previous year questions. They look very similar, but you will not find exactly the same question. So that way you see that it's a new flavor of the PYQ. So that's how we have made these questions. Now, coming to this question, so this particle has been accelerated in a potential difference. So the question is about the speed. How is potential difference and speed related? Try to think. Well, if you accelerate a particle via some potential difference, the electrical energy converts into the kinetic energy. So the electrical potential energy converts into the kinetic energy. The electrical potential energy is charged into voltage difference. Kinetic energy is half m v square. So v square will be 2 times charge into voltage difference divided by mass. Now observe everything carefully. They have been allowed to accelerate via the same potential difference. Delta V is same. Hence, I can say VA by VB the whole square will be 2 cancels, delta V cancels. Charge of A by charge of B because it is directly proportional, and mass of A and mass of B will come like this because it is inversely proportional. Now charge of A and B, it's E and 2E. So it is basically 1:2. Charge of A and B, mass of A and B, it's again, you can see it is M and it is nothing but how much? It is 2M. So basically this is M, this is 2M. So this is 1:2. So basically this will become 1:1. So VA by VB is nothing but 1 by 1. That's the answer. 1:1. Very good, Samita. Awesomeness, guys. Some of you are going to really ace it. By the way, today we had a really proud moment because hundreds of students have got really awesome percentiles and they are rocking in JEE Mains the first attempt, and the results are still being counted because today only the results came out from NTA, and Today whole day I was sitting and analyzing, the JEE paper, and I think there are a lot of things that one can learn because the same NTA is going to make JEE mains as well as your NEET paper. So I'm going to give you a thorough analysis, and this will also help for all the NEET aspirants maybe in a day or two, so you can plan accordingly. Okay, so I'm really hoping, guys, you are going to nail it as soon as the NEET exam comes and the results come out. So I'm very confident because so many enlightened students, so many of my warriors, they have been messaging, sir, now I've got 98 percentiles, I've got 90 percentile, I've got 99 percentile, and now I'm aiming for this percentile, and I'm going to do this. I'm cleared for advanced. I'm pretty sure I'll crack advanced. Thank you for getting a seat into, or giving me a seat into NIT. So these kind of messages are really heartwarming, and I'm pretty sure soon, like this series says, iDoc, you too will say, sir, I'm going to be a doctor. It's just a matter of time. Hold on there, guys. We are still with you. Okay, moving on to the next question. So let's see. As shown in the figure, charges Q and minus Q are placed at the vertices of a triangle. The potential at vertex A is. Miru, if you want to plan for JEE Advanced, there is an Ekalavya batch. It's free of cost. You can join the Ekalavya batch for JEE Advanced. You can just leave a comment after the video maybe, or just search for Ekalavya. You will get it. Oh my God, Anshu, you're in 9th. Good. I'm pretty sure you'll learn a lot. Okay. So let's see how many of you can solve this question. It's a direct question. You should get the answer within maybe around 10 seconds. Some are saying B option. Come on, guys. What about others? Think carefully. What is the potential at this particular point A because of these two charges right over here? Oh, well, it's a tough choice, Rani. Both are good. CSE in Thapar and VIT, both are good. You can, somebody will say CSE in Thapar, somebody will say CSE in VIT. Both are equally good. Okay. So if you have some regional preference, then go for that. Else, just go through the fees. Fees wise, if there is some small difference, VIT is usually costly, Thapar will be cheaper. Okay. So guys, the answer for this is 0. Yep, it is not A. Oops, some of you made a mistake over there, because this positive charge will create a positive potential here. This negative charge over here will create a negative potential. Both the potentials will be equal in magnitude, but they will be opposite in sign. Hence, the net potential will be 0. If the question was on the field, right, then you have to add it vectorially. Potential is a scalar quantity. So don't even bother about the direction. When it was a vector, then you have to think, oh, because of the positive charge, the field will be here. Because of the negative charge, the field will be here. The resultant net field will be in this direction. Yes, there is net field, but net potential is 0. So net potential is 0, but field is not 0. In fact, it is going to be in the horizontal direction. Is that clear? Is that understood? Okay. So why is the charge creating potential diagonally? Charge will create a potential everywhere, bacha. If you take a charge, there is an equipotential line everywhere. Equipotential line. So be it here, diagonal, straight, diagonal, straight, diagonal. Okay. So everywhere there is potential. So field lines are perpendicular to the potential lines. That's how it's creating. So it's definitely creating a potential of same magnitude everywhere over here. Correct? Is that making sense, bacha? All right. So this is very, very important. Moving on to the next question. Here it comes. What is asked over here? Observe. Charges minus Q, plus Q and minus Q are placed at equal distances on a straight line. If the total potential energy is 0, what is the ratio of Q by small q? Okay. So Harika, I'll be doing a class on EMSAT after 17th bacha. Till 17th we'll be focusing more on JEE and NEET, and more on NEET actually, because 17th the NEET exam is there. After that JEE and EMSAT. So charges are placed, the total energy is 0. So what is the ratio of the charges? So let's try to understand. If the net potential energy is 0, that means the potential energy has to be taken in pairs and added. Whenever multiple charges are there, right? Take 1, 2, 2, 3, 3, 4, 4, 1, 4, 2. All pairs I have to take, and then add their potentials, like minus q and minus q, like minus q and minus q, plus potential energy of q and minus q, and potential energy of minus q and q. Their entire sum should be 0. 3 pairs will be there because of 3 point charges. Minus q and minus q, they are separated by 2r distance. So it will be nothing but k into minus q divided by 2r, plus k into q into minus q divided by r, because the separation between them is r. But there are two such terms, so into 2, because this term and this term will be same, is equal to 0. K small q and r will cancel, so minus minus will become plus. So q by 2, this will be minus, and here you will have plus capital Q into 2, nothing else will be there over here, is equal to 0. So basically 2q is equal to small q by 2, and what has been asked is capital Q by small q. So capital Q by small q, bring the small q here, take that 2 over there, so it will be 1 by 4, of course. So that should be the answer, and yes, option C is correct. Option C is correct. LPU is not that great, bacha. Okay, so I hope you understood the crux of the problem, which was taking the total potential energy by adding individual potential energies. They are scalar quantities, don't worry about directions. Also take care of the signs, because charges are sign sensitive, else you'll get some wrong or weird answer. Okay, and take care of the distances, and you can see most of the terms get cancelled out. As simple as that. Moving on to the next question coming up on your screen. Charge plus q and plus q, not plus L, this is plus q, and plus q are placed at L comma 0 and 0 comma L, and minus 2q is placed at the origin. The net dipole moment of the system is. Okay, so for E field, can we apply principle of superposition? Yes, Sagbug. You can apply not only for field, but even for force and even for potential. Okay, so you can also add fields and potentials, but remember one thing, for field you will do vector addition, for potential you will do scalar, just simple addition without worrying about directions. That's the difference. I think we should draw a diagram first and probably then go ahead with it. This is your x-axis, this is your y-axis, this is your origin. See where the charged particles are. Q and Q are placed at L comma 0, 0 comma L. So L comma 0 will be 1 will be here and 1 will be over here. So these are the two charges. Minus 2q is placed over here. This is minus 2q. Okay. The lengths are given to be L and L. So this is L and this is L. So obviously I can see two dipoles being formed over here. I don't know whether you saw that. There is minus q with plus q over here, and another minus q which is remaining with this plus q over here. So there are two dipoles being formed. There are two dipoles being formed. Pradeep, you can crack it, bacha, but you have to work really hard. If you keep wondering whether you can crack or not crack, you will not crack. If you start doing it, then maybe yes. So there are two dipoles. Dipole value, remember dipole moment. Dipole moment. What's the formula for a dipole moment? It is nothing but the charge multiplied by the separation. Charge multiplied by the separation between the charges. So the charge is minus q or plus q, you take any one of them, into the length which is L. So it is nothing but QL over here and QL over here. So these two are the dipole moments. It always goes from minus to plus, remember that, not from plus to minus. So hence the net dipole moment will be QL I cap plus QL J cap. So you can take QL common and it will be I cap plus J cap. Many students make a mistake in the sign, and yes, the option B is correct. They forget that it is minus to plus, they take it from plus to minus, so they get, probably option A. Some people forget that what is the separation. They remember the formula 2L. How many of you remember that formula? Charge into 2L. The moment you remember that formula, 99% you will make a mistake. You will write it as 2 times of L over here. Remember, L actually is the separation here, but in the formula given in many books, including NCERT and so many other books, they write L as the half the distance. That creates a lot of confusion. Don't by heart it like that. I have been telling this to my students because I have seen I have taught almost more than 10-12 years. So I know what kind of mistakes students do. So please don't do that. Just remember separation is L. Don't remember half the separation is L. It's very confusing. Okay. So charge into the separation. Separation itself is L, is the dipole moment. Moving on to the next one. Okay. Sir, the total charge, right? Not because minus 2q at 0, because no, Sagbag, what you are doing over here is basically you're separating it into two dipoles. One is minus and plus. This is one dipole. And this minus and this plus. This is the second dipole. So do you see two dipoles are there? One here and one here. Perpendicular to each other. So minus 2, you have split it into minus q and minus q. That's all. I hope that is fine. Alright, Madhusudan, maybe you should go through the electrostatic lectures which are there on this channel as well. There is a beautiful playlist for electrostatics. Just go through it. You can see that in dipole related lecture it is there. Okay, in case you are not aware where these lectures are, just make sure that you go. So this guy is a hard-working teacher out here. Awesome. So you can watch his lectures. Also the previous lectures as well. Just go to the playlist and all you need to do is go below, down over here, and you can see JEE NEET class 12th and JEE NEET class 11th. All the lectures are there. Just click on the physics playlist or maths playlist. So this is maths playlist. Similarly, you will also have physics playlist right over here. So you can see all the lectures are there right over here. Okay? So make sure you watch through it. Why can't we take minus q as the charge? That's the way it has been defined, Perazagan. Okay? You take the magnitude of the charge, not the value of the charge as plus or minus. So whenever you remember this definition, this is just the magnitude of the dipole moment. Okay? This is just the magnitude. So it's not minus q or plus q. It's just the magnitude. Okay? So any one of the charge. Don't take both the charges, because in a dipole there is equal charge but opposite sign. Total charge is always 0. So don't take total charge. It's any one of the charge into the separation between them. Hello Maruti, welcome aboard. Let's move on to the next one. So let's see how many of you remember the formula for dipole's field, because there is a point which is on the perpendicular bisector of a dipole, and if the distance of q from the dipole is r much larger than the size of the dipole, then the field at the point q is proportional to how much? Hello Guru Pradeep, welcome. So let's start with this. So if there is a positive charge, there is a negative charge, there is a dipole over here. This is dipole. We all know there are two kinds of positions. One is called equatorial, one is axial. This is called as the axial position, and this is called as the equatorial position. Now we all know that at a distance from the dipole, which is much larger, the field will be given by, remember, the field on the perpendicular bisector, which is the equatorial region. The field at point q, which is the field on the equatorial region, is given by k into p divided by r cube. This is the formula on the equator, but the same formula on the axis, will become 2 times of, instead of k, it becomes 2 times of k, p divided by r cube. Remember, on the axis, it's always 2 times of that of the equator. So that 2 factor comes on the axis, the 2 does not come here, but it's okay. We don't worry about that 2 factor. You just have to see what is the field proportional to. It is proportional to p, and it is also proportional to r raised to minus 3. So it's proportional to p as well as r raised to minus 3, which is option D, of course. Yep. Very good, Reshma. Awesomeness. Very good, Mr. Hello, Mr. Chanakya. Welcome aboard. Option D, Darshini. Very good. Hi, Praveen. Good evening. No, it is not C. It is not p square, guys. Okay, it is not p square. P square is not the value for which it is proportional to. On the axis, it is 2kp. On the equatorial, it is just kp on the numerator. Next question coming up on your screen. Here it is. There is a charge q, coulomb, okay, which is placed at the center of a hemisphere of certain radius r meters as shown. The electric flux through the hemisphere in mks units is how much? In mks units, SI units is how much? So first of all, a charge particle always creates electric field around it, and it goes uniformly in all the directions. So this charge particle will obviously create field like this, like this, like this, like this, like this, like this, like this. Now out of that, only a part of that flux will go through the hemisphere. So can I say that the flux through the hemisphere, will be the total flux, which is created divided by 2, because half of the flux goes up, half of the flux goes down, so only half of the flux is going through the hemisphere. So hence it is half of the total flux. The total flux is always Q by epsilon naught, and this 2 will come over here. So Q by 2 epsilon naught is the answer, and I think option C is correcto, and many of you are also correcto about this. Very good, Sanjay, Darshini, Samiha, awesome, Yash, very good. Thank you, Young, for all the love from Kashmir. Moving on to the next one, very conceptual one. Charge Q1 and Q2 are inside and outside a neutral conducting shell. Q1 and Q2 are the induced charges on the inner and the outer surfaces of a shell. The question is, Q1 and Q2 depend on which of the following? See, let's draw a shell first. Shell means it will have a very thin thickness. Okay, this is basically your shell. And you have a charge which is inside. So let's say Q1 is a charge inside and Q2 is a charge outside. Where is it? I don't know, and it's not given also. Okay, there will be some induced charges now. Because of Q1, you will see some negative charges, or I don't know, exactly opposite charges will develop over here. This will be Q1, and maybe because of this guy and that guy, so I don't know, maybe plus minus, I don't know, some kind of charges might also come on the outer periphery. So this will be, let's say, Q2 on the outer side. So the question is, this depends on whom and this depends on whom? Okay, yes, Dr. Manisha, this is what we require to score 150 plus. It's not enough, but it is necessary. I hope you understand the difference between enough and being necessary. This is necessary to score 150, but if you just watch and you do not practice, obviously you will not even get 15 marks. You have to practice. It's like you can watch how operation is done, how doctors do operation on YouTube. Does that mean you can operate? No, right? You have to study. So that's the reason why I say watch and then practice. But yeah, you cannot just perform an operation without watching somebody perform it. So you need to watch and you also need to practice. Both the things are needed. Okay, so guys, what is the correct answer? This inner surface charge, this Q1, only depends on this Q1. Doesn't matter whether it is there or not there, because this conducting shell acts like a shield. This acts like a shield because the electric field in the conducting part is 0. So whatever happens inside stays inside. Also, whatever happens outside stays outside. When you move this charge Q2, the outer charges will get affected, but the inner charge will not be get affected. So, this is also called as the shielding effect. So whenever you take a conductor, you will see when there is a charge inside, you will not find its presence outside. Okay, you will not be able to make out where is the charge inside. Same way, if you have a charge outside and you are inside a conducting shell or conducting a solid, you will not be able to figure out what is happening outside. So that's why I say that this conductors, be it a shell, be it a cube, be it a triangle, be it a pyramid, be it a cone, be it any shape, doesn't matter. They act like shields, electric shields. So they isolate inner part and outer parts because the field in the conductor is always 0. Hence, the answer will be Q1 and Q1. Oh, okay, one second, guys. This, okay. So, one second. The distribution will be affected by Q2, but this total charge, right? This total charge, which will come over here, it will not actually be affected by Q2. The question is not on the distribution of the charges. The question is just on the value of the total charge. Now, this value of the total charge, which is there outside, this will not get affected by Q2. Yes, if you move this Q2 around, these negative charges will move around. But that does not mean the total charge on this will change because of conservation of charges. Conservation of charges. Because if you change the value of Q2, how will it magically change Q2, small Q2 charge? So when you change this capital Q2, then this Q2, maybe the distribution, that means where it is aligned, can change, but the total value of the charge cannot change, because no new charge can be added or can be subtracted. So there is no way to change the total charge on it. There is no way to change the total charge on it. So that's why this Q2 only depends on this Q1. This Q1 depends on this Q1. So indirectly Q1 also depends on Q1, and Q2 also depends on Q1. So hence the answer will be Q1 and Q1. Okay, I hope this is clear. I hope this is clear. Is that understood, my warriors? Everybody with me on this? Okay, clear? Cool. J. Kevin, concentrate on the lecture, not on the outfits out here. Okay, you have come here to see the lecture. Okay, very, very good conceptual question. The question was not on the distribution. If the question was on the distribution, then yes, Q1 will depend on inner charge, Q2 will depend on the outer charge. But it is the total value of the charge, so that depends on the inner charges only, because the outer charge cannot create a new charge over there. That's all. Moving on to the next question, coming up on your screen. Here it is. Sharat Babu, yes bacha, long time no see. You can definitely aim for 98 percentile. How Q1 depends on Q1? Because what's her name? Shri Varshika. What happens is, if let's say there is more charge over here, now there is some charge here. If there is more charge here, then there will be more negative charge here. If you add more charge, then there will be more negative charge here. The moment you create more negative charge, there will be obviously equal amount of positive charge created outside. So this depends on this, this depends on this. So basically this indirectly depends on this. This anyways depends on this. So the inner charge is the one which is affecting both the charges. Okay, I hope this is clear. Okay, moving on to the next question coming up on your screen. Now over here, like you can see, there are two Gaussian surfaces and three charges. The question is, what is the electric flux on the surface A? Now you can see surface A is basically this one. So this is your surface A, and the question is, what's the flux or through that surface? So the net flux through that surface is the net enclosed charge divided by epsilon naught according to Gauss's law. Now what do we do next? Think about it. We have to find out the total charge which is there inside. Now see, whatever the charge is there inside, I think all the three charges are inside. Q1, Q2, Q3. So just add all of them. So what are the charges? So one is minus 14, the next is plus 78, the next is minus 56 divided by epsilon naught. This is nanocoulomb. So this is nanocoulomb. That's it. So minus 56, minus 14, minus 70. This is my plus 78.85. So I think this will become 8.85. Nano is 10 to the power minus 9. Nano is 10 to the power minus 9. Epsilon naught is nothing but 8.85 into 10 to the power minus 12. Both of these numbers cancel. Only one 10 to the power minus 3 remains, which goes up and becomes 10 to the power 3. Hence that should be the answer. And do we have such an option? Yes, 10 to the power 3. 10 to the power 3 should be the answer. That's all. It will only depend. Yep. Oh, no problem, J. Kevin. Okay. So if you just do formulas, it will not be enough, bacha. So I hope you saw what has happened. Gauss's law statement says that the net enclosed charge is going to be epsilon naught is there below, and charge enclosed is there on the top. So the net flux has to be calculated using Gauss's law. Calculate the net charge inside. You saw that the values are very simplified. Hence the answer comes out to be 10 to the power 3. Moving on to the next question. Okay, coming up on your screen. 3 shells A, B, C arranged as shown. The radius are R1, R2, R3. Charges is Q, it's not less than 2Q, 3Q. A, given that the spherical shell A, B and C respectively. Find the surface charge density on the outer shell. Now, whenever you see shell problems or plate problems, remember only two rules. Remember only two rules. What are the two rules? First, charge is conserved. Charge is conserved. Keep this in mind. Charge is conserved. Opposite faces have same charge magnitude wise, but opposite sign. Just keep this in mind. That's it. Your job will be done very easily. Okay. So starting with, and always go from inside to outside. It helps a lot. It is very easier. Starting with the innermost shell, it has a charge Q. Over here. It has a charge of plus Q over here. So opposite to that, there will be minus Q. So plus Q. Opposite to that, the middle shell, inner surface will have minus Q. Now, the middle shell had a charge of 2Q. Inner side has minus Q. So the outer side will have a charge of 3Q, so that by charge conservation, the total charge comes out to be 2Q. Think about it this way. 2Q is what number plus minus Q? Obviously, it should be plus 3Q over here. 3Q and minus Q gives you 2Q. Charge conservation, nothing more, nothing less. Now, what do you need to do next? Think about it. Plus 3Q is opposite to this surface. So opposite to this surface, you will have minus 3Q over here. But actual charge on that is 3Q. So the total charge should be 3Q. Think about it. What should be there on the outer surface so that the total charge is 3Q? Obviously, the answer is going to be plus 6Q, because 6 minus 3 is 3. That's how you go about these problems. So whenever you see shell problems, start from the innermost surface. You will start with 0 because there is no charge inside. If there was a charge inside here, then this will also have some charge, and then you will proceed further. So there is no charge inside, 0, then Q, opposite to Q, minus Q. Since the total charge has to be 2Q, so make this outer surface charge as 3Q. 3Q's opposite is minus 3Q. And to get total of 3Q, 6Q minus 3 will be giving you 3Q. That's how you need to get this. Now the question is not that, the question is the surface charge density. So the surface charge density will be 6Q divided by the surface area of that. So the surface area is the radius given, R1, R2, R3. So it will be nothing but 4 pi R3 square. 6 and 4 cancels. So it will be 3Q divided by 2 pi R3 square. So that is the final answer. That's it. Done, done. Okay. So this is not difficult part. The difficult part is actually finding out the charges and how they are distributed on the shells. Okay. Keep this in mind. Moving on to the next question coming up on your screen. Very good, Samia. Hello, Sai Varun. Two opposite and equal charges when placed this much meter away, then the value of the ratio of the maximum torque and the work done in rotating it by 180 degrees. Okay. This is not for mains, Murari Teja. This is for IDOC. This is an IDOC series. That means it's for NEET aspirants. But yeah, if you want to watch it for mains, you can watch it because portion is roughly similar. Objective type questions only. Difficulty of mains is almost close to NEET, little bit higher. But apart from that, yes, if you want to, you can definitely watch it for mains as well. At least for the easy questions. So if these charges are placed in a field and you rotate it, then what is the ratio of the max torque and the work done to rotate it by 180 degrees? Let's find this part by part. Maximum torque, well, torque is nothing but P is sine theta. Max torque will be when sine theta is 1. Hence the max torque will be just P into E. The maximum value of the torque is just P into E. That's it. Sine theta, P cross E. Sine theta will be 1 when theta is 90 degree. Now, when you rotate it by 180 degrees, the work done in rotating it will be nothing but the change in the potential energy, and the potential energy change will be PE minus of minus PE. Once it is with the field, once it is opposite the field. So the potential energy also changes the sign. Potential energy from PE to minus PE, it will become, plus to minus or minus to plus. So the change in the potential energy or the work done will be 2 times of dipole moment into the electric field. Now, as per the given question, what has been asked? The ratio of the torque and the work done. So torque maximum divided by the work done in rotating it, the work done in rotating it. So it will be PE divided by 2PE, PE cancels, so it will be 1 by 2. That's the answer. These values are completely nonsensical. You don't need those values. Like you can see, 1:2 is the answer. You do not need the values at all. Okay, Miro, I'll start it maybe after a month or two. Okay, not soon. Okay, maybe in August end or something. So very interesting question where these values are not used at all. A lot of students will end up calculating by substitution. You will unnecessarily waste your time. So whenever you see such ratio questions, I usually prefer to substitute everything in the end because some things might actually get cancelled out. So don't substitute initially itself. So Gautam, the reason for P minus P is because, you know, the formula for potential energy is minus PE cos theta. Once theta is 0, other time theta is 180 degrees. So once when theta is 0, the answer will be 1, and when it is 180, it will be minus 1. So one time it will be minus P, one time it will be plus P. So the difference will be 2P magnitude wise. Is that okay, Gautam? Got it? So that's the reason for that. So it has been rotated by 180 degrees. It's clearly mentioned over there. Good evening, Saran. Moving on to the next current, electricity and capacitors part. Okay, so let's see how many of you remember this formula. What is the capacitance of a parallel plate capacitor? Come on, put it up in the chat box. I want to see how many of you remember it. Come on. And if you are late to the lecture, don't worry. You can start off from this part. Okay, we are going to do capacitors and current electricity questions and concepts. This is IDOC series to cover all the important models, and this will help you identify those subtopics or topics where you are weak at. So this is to boost your performance to 120 to 150 marks in NEET physics. If you are a J aspirant, you can still watch it. Okay, come on. What's the formula? Yes, it's epsilon naught A by D, and if there is dielectric material field inside, then it will increase K times. Very good. Very good, very good. Okay, now, okay, tell me one thing. What is the, let's see how many of you can do this. What is the, ratio in which the currents get divided in a parallel resistive circuit? What is the ratio in which the currents get divided in a parallel resistor circuit? Do you remember parallel resistors? Yes. Well, when a current enters in, it gets divided. So in what ratio do you think it gets divided? Think carefully. Well, one which has more resistance will have less current. The one which has less resistance will have more current. More resistance, less current. Less resistance, more current. So guys, it always gets divided in the inverse ratio. So I1 by I2 will be R2 by R1. This is one very important trick which you need to remember for solving parallel resistors problem. Inverse ratio. It's not 1:1. It's always inverse ratio of the resistance. I1 by I2 is R2 by R1. Let's start with the first question on your screen now. Yes, a parallel plate capacitor is charged and the charging battery is disconnected. If the plates are moved away by, insulating handles, so that, you are making sure of something, insulating handles, so there is no flow of charges. The question is, which of the following might change, and by in what way? Will it increase or will it decrease? Only one of them is correct. Only one of them is correct. Yes, Gautam, it will depend on the resistance, like you said. So let's write down the formula. Capacitance is epsilon naught K. Oh, K is not being changed, by D. And Q is also equal to C into V. And energy is nothing but Q square by 2C. These are the formulas which I might need to solve the problem. Let's start with it. First of all, when you basically charge it and disconnect and there are insulating handles, The meaning of these two is that the charge is basically constant. The charge is constant. Charge will not flow in or out, so charge is constant. Cool. If D increases, like it is said, they are moved further apart. That means the value of D increases. So capacitance clearly decreases. Now if capacitance decreases, because charge is constant, voltage will increase. Also over here, if capacitance decreases, the energy stored will increase. So now that we have everything about the capacitor, let's see which of the following will be correct. I think the electrostatic energy stored in the capacitor will increase, which is option D, correct. Voltage will increase, here it says voltage will decrease, wrong. Capacitance increases, no, capacitance decreases. The charge on the capacitor increases, no, it remains constant. Hence answer D is correct. Is that clear, my warriors? Can we move ahead to the next one coming up on your screen? Here it is. There is a figure given below. It shows two identical parallel plate capacitors connected to a battery with switch S closed. The switch is now opened and the free space between the plates of the capacitor is filled with a dielectric of constant 3. What will be the ratio of the total energy before and after the dielectric? Let's try this question out. It's a beautiful question. So first of all, when the switch was closed, okay, when the switch was closed, so when S is basically closed, then the question is, okay, what will be the okay, yeah, both the capacitors will get charged. Okay, now the switch is now open and the free space of the capacitor is filled with a dielectric. Okay, so let's find out the initial energy. The initial energy will be, both the capacitors are in parallel, so their voltage differences will be V and V only. So hence I can say it is half C into V square but into 2, because they are capacitors in parallel. So hence it will just be CV square. That's the initial potential energy. As simple as that. Everybody with me on this? Okay. Now let's do one thing. Let's open up the capacitor. Fair enough. Now what is happening is, this capacitor still has voltage V, but this capacitor does not have voltage V because it is now disconnected from the battery. So for this capacitor, voltage will be constant. Voltage will be constant because it is still connected across this battery. But for that capacitor, it's disconnected. This is a completely different circuit. Here, the charge will be constant. So that's why it's a very interesting, tricky question, which can be one of the difficult questions for NEET examination. But it can come and very few people will do it. So that will improve your score over and above 120, 140, 150, and you can push yourself above that. So let's try this. For this capacitor, you're filling up some dielectric material. Here also you are filling up some dielectric material of constant 3. First of all, what is the value of the charge? The charge will be C into V. That will not change. Q is CV, which will not change. So the final energy will be half. This capacitance will become 3 times because the dielectric constant is 3. So 3C into V square, okay, plus half Q square. Q is that charge, so Q square, but there is a new capacitance which is 3C. Now you just have to solve this. So this will be 3CV square by 2 plus Q square will be nothing but C square V square. 2 3s are nothing but 6 and C. One of the C will get cancelled. So you can see I will have CV square by 2 as common. Here I will have 3 and here I will have 1 by 3. This will become nothing but CV square. 3 3s are 9. 9 plus 1 is 10. So 10 CV square, 2 3s are 6. 10 goes 2 times, this will become 5. 6 goes 2 times, this will become 3. That's it. I have found final and I also found out initial. So all that is left is what is the ratio of initial by the final, okay, before and after. So initial energy is CV square, final energy is 5 CV square divided by 3. CV square goes, it will just become 3 by 5. So it's not very lengthy. This is straightforward. You can easily do it within 1 minute if you know the concepts well. So remember one more thing, I am trying to explain you things over here, so I'll take it slowly. But if I were to do the problem, actually, I would do it within 1 minute. So there are two concepts or three concepts over here. First is, one battery is disconnected for B, it is connected here. So which is connected, voltage will be same. One which is disconnected, charge, which is CV, will be same. Energy formula is half CV square. That's something you need to keep in mind. Also, the next concept here is when you add dielectric material, the capacitance increases K times. That's all. Okay. Why am I adding them? Because I have to find the total energy, right? Even though this is disconnected, this will still have energy, right? So energy of this plus energy of this. So that's why I'm adding them. So one is the energy of capacitor A, the other one is of capacitor B. So I have to add them both to find the total energy. Okay. Okay. I hope this is clear. Let's move on to the next one. Is that okay, my bacha? Sir, if the switch is opened, how will the charge be at B, sir? Nothing will flow through it. Yes, it will not flow through it. But remember, earlier it was closed. Now it is open. So before only it got charged. So charge is constant. When I say that, it got charged before only. It got charged before. Then you opened it. So now the charge is stuck over there. It cannot go out. It cannot come in also. Okay, that's what is happening. Okay, so that's why when the switch is open, you should understand that before it was actually closed, because it is mentioned now it is opened. That means before it was closed. That's the meaning of it. Moving on to the next question. Two capacitors 3 and 6 charged to 12. Okay, they are now connected to each other. Okay, we'll do that later on. First, let's understand only the first statement. There is a 3 microfarad capacitor connected to a battery. There is also a 6 microfarad capacitor again connected to a battery. This is 6 microfarad. This is 3 microfarad. There will be some charge Q1 here. There will be some charge Q2 here. Q1 will be CV. C is 3 micro. Okay, and what is the voltage? It is 12. So it's basically going to be 32 microcoulomb. This charge will be again C into voltage, which is 12. So that will be 72 microcoulomb. So these are the charges on the individual capacitors. Now what has happened? Observe carefully. Their positive plate is joined to the negative plate of the other. This is the crucial part. So if you take one capacitor like this, the other capacitor is exactly opposite, meaning if this is plus, this is minus, okay, then this is minus and this is plus. This is very important. Positive joined to negative, negative joined to positive. The charges will flow, but the total charge should remain conserved. Keep this in mind. The total charge should remain conserved. So the total charge will be positive and the negative together. So the positive charge will be, the higher one is 72. Okay, 72 plus the, oh my god, why did I write 13 over here? This was 36, guys. I'm so sorry. This is 36. Okay, 36. So the positive charge is 72 and the negative charge will be 36, but with a minus sign. I hope you guys understood why it is minus 36. So it ends up being 36 microcoulomb. Is that clear? Is that clear? Very, very important. So the plus 72 connected to minus 36 because of the polarity. So 72 minus 36 is 36 microcoulomb. Now these two capacitors together, I can assume it as one single capacitor because there are two capacitors in parallel. So the C parallel will be C1 plus C2. C1 plus C2. So it will be nothing but 3 plus 6, which is nothing but 9 microfarad. So this is the effective capacitance. And this is the charge on it. This is the charge on it. So the question is, what is the voltage? No, they are not in series, they are in parallel, bacha. They are in parallel because the voltage difference across them is same. So whenever you see such circuits, capacitors or inductors, etc., they are always in parallel because finally the voltage difference between this point and this point, here and here, will be same. So the moment voltage differences are same, it is in parallel, it is not in series. Now all you need to do is remember Q is equal to C into V. So therefore V will be Q by C. Q is nothing but 36 micro. Capacitance is nothing but 9 micro. Micro cancel, so you'll have 4 volts. That's the answer, which is there as option number B. There you go. So the concept over here was, do not try and make more equations. These two capacitors are in parallel, so find C equivalent very easily. Also, you just need to find what is the charge on any one of the sides, either this side or that side. That's also the charge on the capacitor as a whole, which is the equivalent capacitor. So use Q is equal to CV, you shall get the answer. Please keep in mind, if it was mentioned that the positive plate is connected to the positive plate, then the answer will be completely different, because this 72 will then add with this 36. This 72 will then add with this 36, okay? Then it will become completely different. It will become 108 microcoulombs, and then you will divide 108 with 9 to give a completely different answer. Okay? I hope this is clear. Everybody with me on this? Moving on to the next question coming up on your screen. Okay. So guys, if you have doubts, don't worry. You can put it up, like which college to take or whether VIT is good, not good, etc. Please put it up in the chat, in the comment section after the video. I'll definitely try and get back to you, or you can also contact me on captain_Shreyas. That's my Instagram handle out there. So what do we have over here? The resultant capacitance of the circuit is how much? Beautiful question. Let's try to do this. Is this Wheatstone? Is there some symmetry? Is there some disguise? Is this infinite capacitance problem? I think it is a simple series and parallel. You don't have to apply KVL or KCL also. Think about it carefully. These two capacitors are in parallel, so C plus C will just become 2C. This C and this C parallel, so they are going to be C plus C, which is 2C. Now this 2C and this C are in series. Okay, so what will happen? This 2C along with this 2C is basically in series. So the effective capacitance will be now 2C by 2. 2C divided by 2. So hence it is just going to be C. 2C, 2C, 2C by 2. Like when they are in series, divide. When they are in parallel, multiply or add basically. Okay, if you want, I will redraw the circuit so that it looks simpler for all of you. This is point P. You have this capacitance, which is 2C. This entire thing has just become one single capacitance C. And then in between you have that capacitor over here like this, over here like this. And this is going over here to this point over here, Q. Okay, now I think we can solve this further. I'm pretty sure you can see that these two capacitors are again in parallel. C plus C is going to be 2C. Now this 2C and this 2C, oh, there is one more capacitor over here. I need to draw that as well. There is one more capacitor like this. Okay, so that is nothing but 2C. Okay, now this 2C and this 2C will become C. So hence I will just have that P point over here. Okay, and it will just become C over here. Okay, this is point Q, and this capacitor in between, which was 2C. So this 2C and this 2C just became C. Okay, how did I get that? Again, this one and this one are in series. So it will become C. Now this C and this 2C, everybody can see that they are again in parallel. So it will be 3 times of C. That's it. That's the answer. Option A should be correct. Option A should be correct. Yep, it is. So it's only while explanation it takes more time to actually solve the problem. But if you are very skillful and if you can visualize very easily, then you can easily see, oh, C, 2C, okay. This 2C, 2C, okay, series, so it will become C. C and C parallel, so 2C again. Oh, 2C and 2C, C again, so this is C. C and 2C, 3C. So very easily, mentally only you can solve the question. You don't even have to do all these things. Okay, this is just for your explanation, that's all. Moving on to the next question. Okay, yes, it looks easy once solved. Yep, okay. So we have basically 3 amperes coming over here. It gets distributed into 3 ohms and 6 ohms. The question is the ratio of the current in 3 ohms and 1 ohm resistance. In 1 ohm, I already know the current. The only thing I do not know is how much current will go here or here. So let's just assume it. So let's say this is I3, let's say this is I6. I know what to do now. When resistors are in parallel, the current, remember, is inversely proportional to the resistance in parallel circuit. So that's all you need to remember. So hence I3 by I6 will be 6 ohms divided by 3 ohms. 6 by 3 is nothing but 2:1. So I3 by I6 is in the ratio of 2:1. But also remember I3 plus I6 will be 3 amperes using Kirchhoff's current law. It has to distribute. So now it's very simple to see what will be the value of I3 and I6. Mentally only you will get it. So I3 has to be 2 amperes and I6 has to be 1 amperes. So that way they are in the ratio of 2:1, and 2 amperes plus 1 ampere is also 3 ampere. There we go. So the question was, find the current ratio in I3 and I1. I3, I just got it as 2 amperes. I1, I saw it is 3 amperes which is given. So hence the answer is 2:3. That's it. There we go, 2:3. Semiconductor questions, Rami's 18, we solved it yesterday. No, I think on Friday or Saturday. That was block 2, modern physics. It's already done. It's already there in the past videos. You can check that out. Moving on to the next question coming up on your screen. Here we have a network of currents. The magnitude of the currents is shown. The current in this branch I will be how much? Pure usage of Kirchhoff's current law. Come on guys. Can we find potential first and then find the current in each branch? Yes, you can do that, Selva Karthik, but that will be a lengthier method. Okay, so the whole idea of that problem was to remember resistors in parallel, currents divide in the inverse ratio. That makes the problem simpler. Else you can use KVL, you can use V's IR. It's just going to be a little bit lengthier, that's all. Even 15-20 seconds in the actual exam makes a lot of difference, so we should not do that. Okay, so let's try this out. I feel that all these 4 sides I can take it as one single node. Okay, just take it as one single node and then try to solve it. It becomes very easy. So it's just Kirchhoff's current law. In current is basically the out current. The current which is coming in is 10 plus 1 plus 2. So that will be the current which is going out. So I will be nothing but 13 amperes. That's it. Done. Very good. Samiha, Tamil, Kirtika, Tarun, Bala Mukundam. Very good, Deepo. Awesome, Sri Lakshmi. That's the correct answer, like you can see over here. Okay, let's move to the next question. In the circuit shown, the galvanometer G reads 0. If the batteries have negligible internal resistances, the value of the resistance X will be how much? Let's try to figure this out. First of all, okay, we have to find the value of this resistance. Interesting. And this galvanometer is showing 0 reading. That means the current over here is 0. If the current over here is 0, interesting, whatever voltage is there here of 2 volts, the same voltage should also be there across these points B and D. There is no drop here, there is no drop across the galvanometer. So the voltage between C and D should be also the voltage between B and D. Interesting. Now the voltage across this entire circuit, like you can see, okay, in this circuit, if you notice, in this circuit, so which is the circuit that I'm talking about? This circuit. In this circuit, okay, if the current goes here, it just goes here. There is no distribution of the current. So that's a good thing because there is no current in the galvanometer. If there is 2 volts dropped here, this is 12 volts. How many volts will drop across 500? 12 volt is the complete battery supply. There is voltage dropped here and here. This is 2. Obviously, this will be nothing but 10 volts. So 10 volts will be dropped here because 10 plus 2 will give you 12. Is that making sense? Okay. So now I think we can find the current in this circuit using V is equal to IR. V is equal to IR. Voltage is equal to nothing but 10. Current I do not know. resistance is 500. So current is nothing but, right? That's what it is. So 0, 0 goes 1 by 50 amperes. That's the current flowing over here. But the question is not to find the current, the question is to find the value of X. Again use V is equal to IR over there. So again use V is equal to IR. So here voltage is nothing but 2, current is nothing but 1 by 50, resistance is nothing but X. So X will be 2 times 50, which is 100 ohms. That's the correct answer. And let's have a look. Yep, option B is there right over here. So you cannot find the resistance directly without finding the current. You cannot find the current without finding, what is the voltage here. You cannot find this voltage before analyzing the circuit, that there is only one loop in which the current is flowing. There is no current flowing here. So there is no chance of the currents getting distributed and you have to use complicated laws to solve the problem. Initially it looks scary, but you saw the problem is actually 3-4 lines only. That's all. Yes, Samia, that's the answer. Moving on to the next one. So there is a coil. And it is connected to a supply of 220. Some power is dissipated. The coil is cut into half and each of the halves are in parallel. Now the new power is P2. The ratio of P1 by P2 is how much? Let's try this out. First of all, you have this resistor of resistance R which is connected to some voltage. So this power will be nothing but V square by R. Now you cut the resistor into half and you connect them in parallel. So that means you are taking half of the resistance over here and you are taking half of the resistance also over here and then connecting them in parallel across the same voltage V. So what will be the new power now? The new power will be same voltage square but by the equivalent resistance. Do not forget that the equivalent resistance won't be R by 2, it will be R by 2's half. R by 2, parallel R by 2, half of R by 2, which is nothing but R by 2 by 2. Hence it will be V square by R into 4. But wait a minute, V square by R is P1. So it will be P1 into 4. The question is the ratio of P1 by P2. So P1 by P2, because this is P2. P1 by P2 is nothing but 1 by 4. That's the answer. Just check this out. I hope this is clear. Yep, awesomeness. Very good. Ria, why did I take the voltage as 2, not as 12? Okay, very good question. Let me answer that. See, Ria, let me tell you very simple things. Like when you take a resistor, okay, the voltage drop across the 2 points is current into the resistance. Across the resistor. It's not voltage at this point. So if this is V1, this is V2, this V stands for V1 minus V2. Correct? The voltage drop. Here, this 12 is the drop between this point and this point. For the resistor, the voltage drop should be taken across these 2 points. That's why I will take it as 10, because that's the voltage drop across the resistor. So this 12 volts has nothing to do with this guy. It's just the total voltage here. Some voltage is dropped here, some voltage is dropped here. So when I say for this resistor X, the voltage drop between these 2 points is 2 volts. Do you get the difference? Priya, that was a very important doubt you asked, but I hope now it is clear. Moving on to the next one. Okay, and this was straightforward based on ratios and P is equal to V square by R concept. Okay, so let's try this question out, which is again, there are 2 points across which the voltage difference is given. Now the question says, find the resistance X. Find the resistance X. How do we find the resistance X? Think. Okay, I know the voltage difference between these 2 points. Okay, let's do one thing. Let's go from here to here and here and here using, voltage KVL kind of loop equations. So if I start, and VB minus VA is 4, so that means this is lower voltage and this is higher voltage. That's what it means, because VB is bigger than VA, that's why I'm getting positive number. So VB minus VA. Okay, so VB minus VA. So think about it, if I go from here to here, all right, here the difference, because the current, this is high, this is low, the current will flow like this, the current will flow like this, let's say, and it goes like this. Assume this is only one loop, It's not going out, it's not coming in. Let's just assume that the current, oh, but this is 5 volts, this is 2 volts, so I think the current should go that way because current will go in the direction of the bigger voltage. So let's just assume that the current goes maybe like this. Okay, let's just assume that the current goes like this. So then it comes over here and it goes like that. Okay, I'm just assuming that the current is going like this inside this loop. So it's stuck inside this loop. I'm just taking 2 points and I saw that the voltage is 4 volts. That's all I have done, nothing else. So when I go from here to here, there is a drop of minus IR because I'm going across the resistor in the direction of the current. In the direction of the current, the voltage drops. So by how much? Minus I into R, which is 10. Then for the battery, I'm going from the negative to the positive terminal, low to high, negative to positive. It's a climb, so it's a plus over there, which is plus 5. And this is nothing but 4. So 4 is equal to minus 10I plus 5. Bring that 10I over there. 10I will be 5 minus 4. So basically I will be 1 by 10. So I got the value of I. Now look at this part. Look at this part over here. Again, do VB minus VA. So if you notice, I am going from the lower to the higher terminal. If I am going from this point to this point, low to high, so it's a climb, it's a jump, so it's a positive jump. So I'll put plus 2 volts over here. So whenever you go from one point to the other in a circuit, see whether you're going up or going down in potential. Accordingly, give the sign. Now for the resistor, you're going against the current. So when you go against the current, the voltage increases. The voltage drops in the direction of the current for the resistor. So you're going from low to high, so it's a jump. So it is plus I into R. R is nothing but X. So VB minus VA is 4. So this is 2. Current is nothing but 1 by 10 into X. So this will be 2 is equal to X by 10. So X is nothing but 20 ohms. So the sign convention is as follows. So when you have battery, okay, and when you have resistor, never forget this sign convention. If you go from the lower to higher terminal, it is plus E. Okay, it is plus E. And for the resistor, if you go against the current, it is plus IR, against the current. And for the battery, if you go from higher terminal to lower terminal, it is minus E. And for the resistor, when you go in the direction of the current, it is minus IR. So this is the sign convention for resistors and batteries. That's all. Keep this in mind. Very crucial sign convention. This can come as a question which will confuse many kids out there. Many kids are going to make many silly mistakes. So make sure you practice sign conventions, Kirchhoff's voltage law, how to write those equations, when is it plus, when is it minus. If you make mistakes over there, definitely you are going to lose some marks over there. These are actually simple questions, just a play with signs. Two resistors are connected in the graphs of a meter bridge. The balancing point is 20 from the zero end. Let me draw the circuit first. So two resistors, so one is over here and the other is over here, and there is this meter bridge like this, and this is that null point. So the balance point is 20 centimeters from here. That means the remaining should be 80 centimeters. So if this is R, I do not know how much is this. Let's say I put it as capital R. The null point shifts when you add some resistance. Question is, what is the smaller resistance? That means what is small r? Just from this, you can make an equation very easily. Okay, just from the first part. Okay, don't even read the second statement. Just till here. Okay, what you can say, by balancing the Wheatstone, by balancing condition of the meter bridge, this resistor by this resistor is this resistor by this resistor. This resistor's ratio is the ratio of the length. That's all. So basically R by R is nothing but 20 by 80. So 0 0 cancels, it is 1 by 4. So R into 4 is capital R. So this resistance is 4 times of this small resistance. Fair enough. Now for the second situation, now let's redraw it. You are basically adding 15 ohms in series with the smaller of the two. So small r you are just adding one 15 ohm resistance, you are connecting it to the bigger one. Now redraw the circuit. So from here again the galvanometer comes, there is a new balancing length. The new balancing length is 40 centimeters. This is 40 centimeters. Naturally the remaining will be 60 centimeters. Now again rewrite the ratio for balancing condition. So R plus 15 will be R plus 15 divided by capital R will be 40 by 60. 40 by 60 is 2 by 3. R plus 15 divided by capital R is 4 times of small r. Rearrange this equation, cross multiply. So you'll get 3R plus 45 is 2 4s are 8. So 8 times of R. So bring it over there. So 45 will be 5 times of R. So a small r will be nothing but 9 ohms. So that's the correct answer. There we go, option C. Some of you have got it. Awesomeness, guys. Shall we move ahead to the next one coming up on your screen? Here we go. 5 resistors are connected in the combination as shown. The equivalent resistance between A and B is how much? Okay, whenever you see these kind of questions, you should always think about Wheatstone and see if Wheatstone's bridge is actually balanced or not. Check the ratio 5, 4, 10, 8. I think 5 by 4 is 10 by 8, so it is balanced. So the moment it is balanced, you can completely get rid of these resistors which are there in between. Now 5 ohms and 4 ohms are in series. So 5 plus 4 is 9 ohm. This 10 and this 8 are also in series. This is 18 ohm. 18 ohms and 9 ohms, they are in 2 different branches side to side. Hence they are in parallel. So hence the equivalent resistance will be 9 into 18, which is R1 R2 upon R1 plus R2. 9 plus 18. So this will be 9 into 18 divided by 27. 9 goes with 27 3 times, 3 goes with 18 6 times. Hence the correct answer is 6 ohms. Done, done, done. Straightforward. Time to move to magnetism. Okay, let's talk about magnetic effects and forces due to magnetic fields on moving charges or current carrying conductors. So let's try to do this question. A circular arc of wire of radius of curvature r subtends an angle of this much at its center. If the current is this much, then what is the magnetic field or magnetic induction at the center? So if you take a coil at the center, the field is given by mu naught I by 2r. But if it is an arc which subtends certain angle, then the magnetic field is given by mu naught I by 2r into theta by 2 pi. So this theta by 2 pi will come over there. Just put it now and you will get the answer. So guys, the magnetic field will be mu naught I by 2r. Theta is given to be pi by 4 divided by 2 pi. So you can clearly see this will be mu naught I, pi cancels. 4 into 2 into 2 is nothing but 16. 16r should be there. That's a direct answer. We will get it as option C. So whenever it is a complete circle, it is mu naught I by 2r. When it's an arc, just multiply it by theta by 2 pi. It is a fraction. Theta is the angle, 2 pi is the total angle. How much fraction of the total angle you are subtending, that's what you need to multiply. That's all. Okay, moving on to the next one. A current of 1 ampere enters from one vertex and it exits from the other. Find the field at the centroid. Very interesting question. So these kind of questions you can solve it directly. I'll give you a trick. The current enters from here and exits outside. Now whenever a current enters here and exits outside, whenever such polygon related questions are there, the question is find the field at the center. Remember, the currents don't divide equally because here the resistance and here the resistance are different. This is just one side. Here the current has to go like this. So in fact, the currents divide themselves like that. This is R, this is 2R. So 2:1 will be the ratio of the current. 2:1 will be the ratio of the current. So currents will divide basically. Now this current will create a magnetic field, let's say inside. Then this current will create a magnetic field outside and they both will end up cancelling each other. They both will end up cancelling each other. Now this is not just true for this, but you can take any such polygon, be it a square, be it, let's say, a hexagon. Okay, be it a hexagon, the current comes here and it goes from here. The current comes here and goes out from here. Whenever such diagrams are given, the field at the center is always going to be zero, because the currents get divided in such a way that they produce opposite magnetic fields and they balance each other and they will cancel to give zero. So hence the answer is option D. So you don't even have to solve it. These values are just given to confuse you. A lot of students are going to just waste their time. So this is true for all kinds of polygons, symmetric polygons. Okay, the current should come from one point and it should go from any point, need not be adjacent vertex. Like you can see, it's not adjacent, it could be any vertex. The answer will always come out to be zero. Keep this in mind. Okay, moving on to the next one. The question is, there is a current carrying coil of certain radius. The distance from the center of the coil on the axis where the magnetic field will be 1/8 the value of the center of the coil. So let's try this out. So first of all, the value of the field at the center of the coil, I can just call it as B naught, is mu naught I by 2 times of R. That's the value. Now, if you take a coil and if you are on the axis, then here the magnetic field is given by mu naught I R square by 2 R square plus X square. Now, according to the given question, B is 1/8 of B naught. This is nothing but 1/8 of B naught. So let's try and substitute it. So mu naught I R square by 2 times, oh sorry, this is raised to 3 by 2 guys, that raised to 3 by 2 is there, 2 times R square plus X square raised to 3 by 2 is equal to 1/8 B naught. So just substitute the value, which is nothing but mu naught I by 2 times of R. Well, many things are going to just get cancelled, like mu naught, I, correct? And you can see this 2 and this 2 will also get cancelled. 8 goes here with R and this whole thing goes on the other side. So let's see what happens. It will become 8 times of R cube will be R square plus X square whole raised to 3 by 2. Whole raised to 3 by 2. Take 8R over here, so 8R cube, and this guy goes over there. Now take cube root on both sides. 8R cube's cube root will be 2R because 2 cube is 8. Here when you take cube root, you will just be left with R square plus X square raised to half. Now square both sides because I want to remove the root. So it will become 4R square is R square plus X square. So bring it there. So 3R square is X square. So X will be root 3 times of R. That's the answer, which is option B, of course. Option B, you can see that. Awesomeness. So option B is correct. So you should know the formula for magnetic field at the center of the coil and also on the axis of the coil. If you know it, that's it. It's going to be very straightforward. Moving on to the next question. Rest was just squares and cube roots and all of that. I'm pretty sure you can get there. Now, there is a beam of protons moving horizontally towards you. As it comes towards you, it passes through a magnetic field directed downwards. So the question is, where does the beam deflect? Don't look at the diagram, you visualize it yourself. The charges, the protons are coming towards you. So that means the velocity is coming towards you. As it passes, there is a field directed downwards. So the magnetic field is directed downwards. Question is, what's the direction of the force? Come on, use this formula, QV cross B. Everybody use your right hand. Velocity is towards you. Magnetic field is downwards. So 4 fingers pointing towards you and then going down. See where is the thumb going. The thumb is going this way. It's going this way. Hence the force will be towards your right side. Hence the correct answer will be option B. As simple as that. As simple as that. So it's just based on your right hand rule, cross product. That's it. Option B is the correct answer. Very good, Rajesh. Awesomeness. Next question. There is a proton of some energy moving in a circular path in some field. The energy of an alpha particle in the same field and the same path will be how much? Okay. Now one thing you should know, whenever you take a charged particle and throw it inside a field, it goes in a circular path, and the circular path has some radius. So basically the radius of that circular path is given by mv by qb. Interesting. Okay, the energy has been asked. Interesting. So let's see what we can do. How about maybe just multiplying by, oh, I can do one thing. mv is nothing but momentum. So this is momentum by qb, and momentum is nothing but root of 2 times mass times kinetic energy, standard formula, correct, into this divided by q into b. That's your radius. Okay. Now as per the question, the things which are same path, that means r is same. So r is same. Field is also same, in the same magnetic field. So b is same, r is also same as per the given question. Charge will be different because one is a proton, second one is an alpha particle. Kinetic energy is asked. Mass is also going to be different, proton and alpha particle. So from this, what did I get? From this, what did I get? Root of mass into kinetic energy divided by charge is basically same for both. So basically mass of proton, if I take it as m on this side, mass of the alpha particle, I will take it 4 times of m. Proton, alpha is 2 protons, 2 neutrons, so 4 times. Now kinetic energy on this side is 8 electron volts. Here I do not know the kinetic energy. Divide by the charge. Here the proton's charge is E, the alpha particle's charge is nothing but 2E. E cancels, mm also cancels. So root of 8. So root of 8 is equal to root of 4. Root of 4 is 2. So 2 root k divided by 2. 2 cancels. So basically root 8 is equal to root k. So k obviously has to be 8. So this is the energy of the alpha particle. So hence the answer is C, of course. Yes, Chandraj Jasti, obviously it will be helpful. Okay. So very, very interesting question. You have to understand what it means. When it says the path will be same, that means the radius will be same. Field is same, that means B is same. 2 is a constant, mass, K and Q could be different. So you're just saying root mk by Q will be same for both, and you are equating the 2 terms for alpha and proton. That's all, and you will get the answer. Moving on to the next one. So here we have 2 things. One is a long wire and one is a loop. The question is, what will happen to the net force and the torque on that loop? First of all, because of this current carrying loop, I think there will be a field inside. So the field will be obviously directed inwards. The field will be directed inwards like this, correct? But as you go far away, the field will become weaker. Here it is strong, here it is strong, here it will be weak. Here it will be weak because as you go far away from this wire, the field will become weak. So what will be the force acting on each part? I think we can figure that out. For this part, if you use this formula, F is IL cross B. IL cross B. Length of the wire is upwards, magnetic field is inwards. Length upwards, field inwards. The thumb comes this way, so the force will be here. On this part, it will be obviously opposite, and on these 2 parts, it will be one will be like this and one will be like this. Now, don't think all the forces will cancel here. Reason is this F1 and this F2 will not be equal because here the field is strong, here the field is weak because of the distance. So technically speaking, F1 will be more than F2. So the net force will be actually F1 minus F2, and that will be directed towards this side, towards the left side. So it will attract that loop. It will attract that loop. F and F over here, or you can just call it F3 and F4. This F3 will be equal to F4. Okay, so there will be no movement in the vertical direction. Talking about torques, these 2 forces are along the same line. These 2 forces are along the same line. They are not going to cause any rotation. They are not like a twisting torque. Okay, one is not, even though they are opposites, they are not causing any rotational effects. So there will be no torque because of this. So the net torque is 0 because all the forces, be it F1, be it F2, they all meet at one point. They all meet at a point. So they are concurrent. So whenever they are concurrent, the torque will be 0. Remember, when forces are not concurrent, like for example these two forces, they will form a couple force and they will produce a couple torque because they are not meeting at the same point. Here all the forces will meet at one point, so that's why it will not produce any torque. Hence attractive and 0 should be the answer. It's a beautiful question. Moving on to the next question. Again, it's a very realistic question. Let's see what is given. A beam of Q by M value, charge by mass ratio is given, is this much, passes through a field and electric field, both acting simultaneously. Okay, the electric field is removed. What will be the radius of the electron path? Actually, it should be given. It passes undeflected, should be given. Passes undeflected through a magnetic field and electric field. If electric field is taken out, what will be the radius? Okay. Now, whenever charge passes undeflected in electric and magnetic field, such situation is called as a crossed field. Such situation is called as crossed fields, and in such a case, the velocity of those charged particles is the electric field by magnetic field. It's a very standard value. Standard derivation is there. It's being done many times. You can check it out. It's a standard result which you are supposed to remember. Now what you have done, you have removed the electric field. So that means magnetic field is still there. So in that case, you will see that the charged particle will go in a circular path. So that's the question. What's the radius of that circular path? So that's going to be mv by qb. V is not known, so that value you will get it from here. So you will get this as m by qb, and velocity you are going to put it as electric field by magnetic field. So this will be m e by q b square. Now these values are given directly, like q by m. Okay, q by m is 10 to the power 10. So this will be 10 to the power 10. Then electric field is given to be 10 to the power 4. Magnetic field is 10 to the power minus 3. So this is 10 to the power minus 3 whole square. Now 10 to the power minus 3 whole square is 10 to the power minus 6. So this will become 10 to the power 4. 10 to the power minus 6 and 10 to the power 10 will become 10 to the power 4. Oh, this will just become 1. So hence the answer should be 1 meter. Answer is yes, Anisha, it is 1 meter. So beautiful question of 2 or more concepts. The first concept being of crossed field. Whenever the fields are perpendicular, that's the only way the charge can go undeflected, provided the speed is E by V. Now, if you turn off one of the fields, it will go in a curved path, and especially when the magnetic field is there, it will go in a circular path. Speed was not known, speed was found from here, substitute, and you will get the answer. Beautiful question. A circular coil of mass m. In this coil, in this coil a current I is flowing. It is placed in a field. The time period of small oscillation when disturbed from its equilibrium position will be how much? Okay, let's try this out. So usually what happens in these kind of questions, the time period of oscillation is given by 2 pi under root moment of inertia divided by mb. So this is the time period. This is the time period of oscillation of magnetic moment in external field. This is standard formula. If you do not remember it, please remember it at least from now on. Time period is 2 pi under root moment of inertia by magnetic moment into field. Now you just need to find out the magnetic moment and moment of inertia. So first of all, it's a coil, so it will obviously try to oscillate like this. You need to find the moment of inertia about this axis. So it's not known directly, you have to use perpendicular axis theorem. So I know the moment of inertia about this axis, which is m into r square. So each of these axes will be I and I because of symmetry. They are, whether you rotate like this or rotate like this, it's the same thing. So using perpendicular axis theorem, I plus I is mr square. So I will be mr square by 2. This is mass, not magnetic moment. Now talking about capital M. Magnetic moment is NIA. Number of turns, it's just one coil is 1. Current is just I. Area is just pi r square. So it's just going to be pi I r square. So just substitute it and let's see what do we get exactly. So 2 pi root of one of the b will remain. And now let's start substituting. Pi is there, I is there, r square is there from that m. And from here you can see small m is there, r square is there, and that 2 is there. R square cancels. Pi, root pi. 2 and root 2 and 2, again root 2. So I think I'll be left with, you can take this 2 inside, pi also inside because root 2 will be remaining, root pi will be remaining. I think this small m will be there, r square has just cancelled out, pi has cancelled, even 2 has cancelled, r square has cancelled, I is there and magnetic field is there. So that's your time period. That's it. Done. Option is not given. You just have to figure it out. One of the options will be this. So you are just going to sit and mark that option. As simple as that. Okay, beautiful question. Okay, so multiple concepts are there. 3 chapters are there in this one question. This can come in section B of your NEET examination. Okay, one more question. Here we have one more question on electromagnetism, and let's see what it is. There is a coil of certain current and it has some magnetic moment. You change the shape of the wire to square. Now it carries the same current. What is the new magnetic moment? Okay, definitely Selva Kumar, you can do that. That's a good way of studying it. So first of all, it's a coil which carries some current. It has some radius. Obviously it has some magnetic moment. So that magnetic moment will be NIA, number of turns 1, current I, area is pi r square. So it's I pi r square is the magnetic moment. Now you take the same coil and convert it into a square like this of some side A. It will have a new magnetic moment, let's say M1. That M1 will be NI into side square because that will be the area. The problem is I do not know A. Let's find that out. How can I find it out? Let's see. But before that, what do I need to do? Let me just take the ratio of these two. So M1 by this will be IA square. This whole thing divided by this M and this whole thing I pi r square. I want to get rid of A somehow because the same loop has been converted into the square loop. All I can say is the perimeter will be same. So 2 pi r will be equal to the perimeter of the square, which is 4a. So a will be nothing but pi r by 2. So this 2 gets cancelled, that 2 comes below. So pi r by 2 is the side of the square. So substitute it over here. So this will be I has got cancelled. So let's not even bother writing that. So I got cancelled. And what is remaining? Oops, sorry guys. What is remaining? A is nothing but pi r by 2. So a square will be pi square r square by 4. I has got cancelled. So pi is there and r square is there. Okay. So pi, one of the things remain, r square goes. So that's it. So pi by 4 will be the answer over here. So that's m1 by m. So m1 will be pi m by 4. Pi m by 4. Let's just check that out. Yes, it is pi m by 4. You can see that. Pi m by 4. So you can see that from here. M1 will be pi times m divided by 4. That's what you wanted. So the concept here was remembering magnetic moment formula. Second was perimeter is same. So that's why I can equate them and you can find out the new side length. Let's go to the last part of today's class, and that is EMI, electromagnetic induction. It's all about Faraday's law, Lenz's law, motional EMF and inductances. Okay, so these are the 4 major concepts in your EMI chapter. So let's see the first question over here. There is a solenoid which carries current. It is approaching a conducting loop. The direction of the induced current as seen by the observer is in which direction? Okay, so let's try this out, guys. First of all, this is a question completely based on Lenz's law. Lenz's law. What does Lenz's law say? If you do something, it will oppose it. So just try to oppose. If you try to come towards, you are going to repel it. If you are going to go away, it will basically pull you back. So it will attract you. So just try to do exactly opposite of whatever it wants to do. Now, this solenoid is going towards it. It's going towards it. So if it is going towards it, is going to face some kind of repulsion. So it is definitely going to repel. But I do not know the polarities. So let's use our right hand rule. See how the current is going on the solenoid. It's going like this, right? It's going like that. So curl your fingers. See where your thumb is. Wherever your thumb is, that is the north side of the coil. So this is the north side. This is the south side. Is everybody getting it? So this is the north pole, guys. This is the north pole. This is the north pole of the coil, of the solenoid, and this is the south pole. How did I get this? Using right hand rule. So I just curled my fingers like this. I saw that the magnetic moment was this way. That's all. To repel it, obviously this coil should produce its south pole in front of it. This coil's south pole should be here, north pole should be here. Correct? Only then it will repel. South repels. If it is north-south, it will attract. You want to repel it by Lenz's law. So from south to north, that means you will have a magnetic moment like this. So south to north. Hold your thumb from south to north. Thumb will go from south to north. The finger will curl like this. The finger will curl like this. So if I am the observer, for me, this direction was anti-clockwise. This is anti-clockwise. So hence, I am going to mark anti-clockwise right over here. So that is option A. So it is going to be anti-clockwise, guys. So the current is going to go like this and come like this. So it's going to be anti-clockwise. Everybody with me on this? So this is how you're supposed to solve these questions. Remember the simple rule, Lenz's law is all about opposing whatever it wants to do. So just try to oppose it. If it wants to attract, see how the polarity should be. If it wants to repel, see how the polarity should be. And remember, the right hand thumb rule is going to help you a lot. Next question. Here we come. There is a loop which is placed in a magnetic field where the flux is changing. Flux is in milliweber, T is in seconds. The magnitude of the EMF in the loop at 2 seconds is how much? Now, if you notice, because the flux is variable, so even the flux inside that loop will change. And when flux changes, by Faraday's law, EMF is created. And according to that, the magnitude of the EMF, because I'm just interested in the magnitude, is given by d phi by dt. Flux is nothing but field into area. Are there any turns over here? I think there is only one turn by dt. Field is changing, area is not. So it will be A into dB by dt. So that area is a constant which comes outside. Is the area given? Oh, wait a minute. B is not changing. I mean, it might be changing, but I do not even have to bother about B. Directly flux is given. So I don't even have to do all of this. This is not even needed. So just take the derivative directly. Okay. Flux is directly given as a function of time. So d by dt of 3t square plus 2t plus 3. Now this will be nothing but 3t square's derivative is 60, 2t's derivative is 2 into 1 because t's derivative is 1, 3's derivative is a constant, so it's 0. So it's 60 plus 2. This is EMF. So EMF at 2 seconds will be 6 into time is 2 plus 2. 6 2s are 12, 12 plus 2 is 14. Now be little careful over here. A lot of you are going to say option A, but answer is C, because be careful here, this is milliweber. So all of this time there was a milli term over here, milli. So because of that milli, this will be millivolt. Okay, so a lot of students will make a silly mistake. This is very bad mistake. So answer is C. 14 millivolts is the answer. This is basically, I mean, more than silly mistake, this is called as misreading. You have not read the question or you have ignored the data. That is why you have got that answer as A. Moving on to the next one. Okay, so guys, what do we have? The distance of a wing of an aeroplane is 5. The aeroplane is going down with some speed of 100 at an angle of 30 with the horizontal. The horizontal field is given to be this much Gauss. The induced EMF will be how much? Okay, beautiful question. First of all, the wing of an aeroplane, okay, this is the wing of an aeroplane, this is that plane like this maybe, okay. Now the distance of the wing of an aeroplane is 5 meters, so this is basically 5 meters. So the total length is basically 10 meters, and this is going down at 30 degrees with the horizontal. So if the length of the aeroplane is along this line, the length of the wing of the aeroplane is along inside and outside of the board. If this is L, the plane is coming like this, okay, and it makes an angle of 30 degrees, and the horizontal component of the Earth's field is given to be 0.4 Gauss. The question is, what is the induced EMF of that plane, on that wing of the plane? So I think I'll be just using the induced EMF will be B, L, V, and only take that component which is perpendicular to the length and field. Never take the parallel components, only take the perpendicular components, which is V sine 30. So actually it is V perpendicular, always take the V perpendicular, that's the formula. Now substitute everything. Magnetic field, 0.4 Gauss is 0.4 into 10 to the power minus 4 Tesla. Convert everything into SI units. 0.4 into 10 to the power minus 4 Tesla. Length, a lot of people will not take it as 10, they will make a mistake, they'll just take it as 5, misreading the question. It's clearly mentioned it's the length of a wing. So that's why it is 10 into V perpendicular. Be careful, V perpendicular, which is V sine 30. So it's 100 sine of 30 degrees. That's all. Now you just have to solve the question. So this is going to be 4 into 10 to the power minus, 0.4 and 10 will get cancelled, so that one decimal will go away, into 100, which is 10 to the power 2, and this is sine 30, which is half. So this goes with this 4, this will become 2, so it will become 2 into 10 to the power minus 2, so that is in volts, so that is 20 into 10 to the power minus 3 volts, which is 20 millivolts. That's the answer. That's the answer. No, it's not 1, it's 20 millivolts. 20 millivolts. So that's actually the voltage which is created across the ends of an aeroplane, okay, when it flies down. That's very interesting question. First concept which many students miss is V perpendicular. Second concept, not taking the length correctly. Third mistake, forgetting to convert Gauss into Tesla. 1 Gauss is 10 to the power minus 4 Tesla. Keep that conversion factor in mind. Next question coming up on your screen. There is a coil of this much side, this many turns, rotated with some speed in a field. Then at some instant the EMF is this much. What is the magnetic induction? Okay, now this is a standard question. Whenever you have a coil and you rotate it, okay, inside some magnetic field, let's say this is the magnetic field, then the EMF which is created is born BA omega n sine omega t. This is the concept of your AC generator. This is a standard concept, born sine omega t. You should know this. Now just compare the two, you will immediately understand what is what. From here you can clearly see 100 pi is basically omega, born sine omega t, and this 200 is basically born BA omega n. That's it. Now start substituting. 200 is equal to, magnetic field has been actually asked, so B I will keep it as it is. A, area I can find out by squaring this, 25 square centimeters, so 10 to the power minus 4 meter square. Omega from here is 100 pi into n, number of turns is nothing but 10 to the power 3. So this will become 25 square is 625 into B into pi will also be there into 10 to the power minus 4, 10 will get cancelled. So one of the tens will be there and this will be 200. This 0 cancels. So field will be 20 divided by 625 multiplied by pi. Now I can do one thing. Okay, over here I can just write it as 20 divided by 6.25 multiplied by 3.14 into 100. Okay, why did I do that? Okay, I know I can do one small approximation. Look over here, 6 3s are 18, correct? 6 3s are 18. 6.25 into 3.14 will be slightly more than 18, somewhere close to 20, very close to 20. So won't this number and this number cancel out? This number and this number roughly cancel out. So I'm just left with 1 by 100, 1 by 100 over there. So 1 by 100, this is approximately, this will be what? Tesla. So that's the answer. So 1 by 100 is 0.01. Option D, of course. Okay, is that clear? Beautiful question on how you can actually do some approximations. 6 3s are 18, 6.25 to 3.14 will be slightly like 20 point something maybe. So just cancel it out, make it more simpler. Moving on to the next one. Here it is. There is a coil, 500 turns, rectangular frame of area 4, resistance also given. The coil is kept in a plane with uniform field of this much. Charge which flows in the coil if it is turned over. Okay, let's try to understand, make sense out of it. There is a coil, it has some area and maybe there is some field. This is initial. Now what you do is you flip it over. The moment you flip it over, the area vector will be here, magnetic field will still be there. Magnetic field will still be there. So in this process, you have changed the area. So B dot A, which is the flux, will also change. Because the flux will change, electricity will be created, current will be generated, charge will flow in the coil. Question is how much charge will flow. First thing to do is how much flux changes. That's the main concept here. So the change in the flux, okay, the change in the flux magnitude wise will be final flux minus initial flux, again magnitude wise. Just interested in the magnitude, that's all. So final flux is nothing but BA cos 180, BA cos theta, that's the value of the flux, minus BA cos 0, modulus of that. Now this will be nothing but minus BA, because cos 180 is minus 1, cos 0 is 1, so this is again minus BA. So magnitude wise it is just 2 times of BA. So from BA it became minus BA, so the change is twice BA. Now start solving the question. Okay, so EMF is del phi by del T and current is EMF by R, and current is also the charge which goes per unit time. EMF is nothing but del phi by del T cancels. So the charge which flows is 1 by R into del phi. Del phi is nothing but twice BA. Now substitute everything. The resistance of that coil is 50 ohms, so put 50 over here. 2 times field. How much is the field? The field is 0.2, that's SI units. Area is 4 centimeter square, so 4 into 10 to the power minus 4, and do not forget it has 500 turns, so you have to multiply it n number of times, so into 500. Now just sit and solve this. I think you should get this. 550 goes with 500 10 times. Now this 0.2, I can take the decimal over there. 2 2s are 4, 4 4s are 16. So 16 will come here. The decimal and the 10 goes into 10 to the power minus 4. That will be coulombs. 16 10 to the power minus 4. I think it will be 1.6 into 10 to the power minus 3. You can shift the decimal, of course. So this, you can shift the decimal, you will get this as the answer. Beautiful question on flux change. So a lot of people think when you change it by 180 degrees, flux will not change. No, in fact, change it twice. Very similar to a mass which hits a body and reverses the direction, the change in momentum is 2 mv. So always remember, whenever things get reversed in physics, the change is always twice of the initial value. Like change in momentum becomes 2 mv. Here change in flux becomes 2 BA. There was one more question where energy was minus PE, it became plus PE, the change was twice PE. So So many questions are there, concepts are there where the changes are twice when you reverse the direction. Moving on to the next one. A rod of certain length moves with uniform angular speed through the middle point normal to the length in a magnetic field, okay, which is parallel to the axis of rotation. What is the EMF between the two ends of the rod? Let's visualize this. So there is this rod and it is rotated like this, okay, and the magnetic field is here. Well, we all know each part of the rod behaves like a battery. So this is going to behave like one battery like this. This is going to behave like one battery like this. And this part is also going to behave like one battery like this. Now the question is, what is the EMF between these 2 points? Guys, if this is 0 volts, this will be plus E, this will be also plus E. The question is, what is the difference between these two? The answer will be, the voltage difference will be 0. E minus E will be 0. No potential difference. Hence, option B should be correct. Yes, it is. If it was any one of these parts, so when you take a rod of length L and rotate it inside, a magnetic field, then the EMF is half B omega L square. That is a different completely problem. Okay, here there are 2 such rods. So the question was, find out the voltage difference between these 2 points. Completely unexpected. A lot of people get some either C option or A option, but that is not correct. Okay, moving on to the next one. Here it comes. 2 coils X and Y are placed in a circuit. The current changes by 4 amperes in coil X. The flux changes by 0.4 in coil Y. The value of the mutual inductance. So there are 2 coils. There is one coil here and there is one coil here. This is coil X, this is coil Y. The current changes by 4 in coil X. So the change in current here is 4 amperes. The flux which will be passing through this, how much will the flux in Y change? That's the question. So here what we need to do is use the definition of mutual inductance. Remember, phi is Mi, so del phi will be M into del I. So M will be, del phi is given, I think. I'm so sorry guys. Del phi is given. Del phi is given. How much is del phi? The change in the flux is 0.4. This is 0.4. So the question was mutual inductance. Okay. So to find M, because the value of mutual inductance is asked, which will be del phi by del I. So that's going to be 0.4 divided by 4, which is nothing but 0.1. That's the answer. 0.1 Henry, of course. 0.1 Henry, of course. Option D is correct too. Everybody with me on this? Can we go ahead with the last question, hopefully? Yes, here it comes. The self-inductance of a coil does not depend on. Everybody should answer. Come on, guys. What is the answer to this question? Figure this out. What should be the answer to this question? Think about it and answer. So, self-inductance does not depend on which of the following? Self-inductance. So whenever you take a coil, okay, the self-inductance phi, which is equal to Li, this depends on what? The area of the coil. Yes, it does depend on the area of the coil. It also depends on the number of turns, correct? It also depends on the permeability. But what it does not depend on is the current. This L does not depend on the current, rather the flux depends on the current, or the current depends on the flux. L is a completely independent thing. It depends on area and mu. So number of turns, yes. Radius, because area. And magnetic material, yes. So hence the correct answer is the current in the coil. Lot of students feel that L depends on the current. If current is more, L decreases. No, if current is more, flux increases. L depends on the coil's radius, magnetic material, turns, length, etc. So that was our unit 3, our block 3 of electromagnetism. All the important concepts which are there for NEET examination, I have tried to cover it up via problems. Now I want you to please solve all the problems which you could not get, more of them, especially via the assignments. Now obviously there are more such things which you need to do in the days to come. And how will you understand what is that you do not know, what is it that you actually need to work upon? That will only happen via mock test. Now, rather than searching for mock tests online here and there and registering at 100 places which does not give you proper report cards, I would say go down in this chat box right now over here, okay, in this description box. You will see that there are multiple options available here. Okay, there is also test series. So click on this NEET full mock test series and you will see mock tests available right for you over here. Not just that, you will see if you go to the NEET crash course light version over here, you will see you will not only get 20 mock tests but also interactive sessions in the last few days and 500 practice quizzes, plus also you will get hundreds and hundreds of problems, 2000 top questions for NEET created by experts, along with doubt solving and tips and strategy sessions. So all of this is just there for 1,800 rupees. You can go ahead and click on buy now, use the coupon code SHHPRO to make the best use of this. All right, so that's the NEET crash light version, which I think is going to be beneficial for all of you even in the last few days because of mock tests, thousands of problems, doubt solving, and also if you face any difficulty in a chapter, you can watch the recording. Okay, thank you very much for joining in, guys. I hope you learned a lot. Have a great time and stay safe, and please work really hard in the last 1 week. Bye bye. See you in the next class. Hasta la vista.